All right, so here's a video so that you can check your work on that mixed practice. Okay. I did want you to go through and work on it yourself before you went back and watched through the videos to see what you're doing. So when we are doing these are all mole conversions. So you need 3 equations. 1 mole equals 22.4 liters. 1 mole is equal to 6.02 times 10 to the 23rd somethings. Okay, there's a million different names. Anytime you see something with a high exponential value, you're probably doing the second unit conversion. And the last unit conversion is molar mass. Okay, so every single time you're going to use 1 or 2 of these items. Okay, so let's start with the first problem. Same rules as always. Known goes on the left, equals question mark unknown. There are 60.0 grams of water. That's the one with the number, so that's our known, equals how many molecules? The one with the question is our unknown. It goes on the right. So our pathway is going to be grams to molecules. If you don't see moles, it goes in the center. Moles has to be somewhere in this because these are mole conversions. So this guy is going to have a first unit conversion from grams to moles and a second unit conversion from moles to molecules. How do we set up the equation? Start with the known, 60.0 grams over 1. How many arrows? 2 arrows, 2 unit conversions. Okay. Our first unit conversion is from grams to moles. Grams is the known, moles is the unknown. Knowns go on the bottom, unknowns go on the top. Now I'm going to continue on and set up the second unit conversion, then I'm going to go back and fill in the answers. The second unit conversion is from moles to molecules. What's on the left? The known is always on the left. That moles was on offense before, and now he's on defense for the second half. Okay? And the unknown is molecules. So the known is moles because he's on the left. The known goes on the bottom. The unknown goes on the top. Now that we have that set up, you can notice that we can cancel. Grams on the top, grams on the bottom, moles on the top, moles on the bottom. What else have you noticed? Moles for module 4 is always 1. Anytime you see moles, unless it's the known or unknown, it's in a conversion, it's 1. That changes for module 5, but for module 4, whenever you see a mole in a conversion, it's 1. Whenever you see a molecules or something, molecules, atoms, formula units, compounds, there's a whole list. That's when you put in the number 6.02 times 10 to the 23rd. Okay, so now let me rewrite that so we can see it a little bit better. 60.0 times 1 times 6.02 times 10 to the 23rd is what's left in the numerator. They're all connected by multiplication. And in the denominator, I don't have everything yet. I need to know the grams in 1 mole of water. That's molar mass. Okay. There are 2 hydrogens and 1 oxygen. Hydrogen has a mass of 1.01 from the periodic table. Oxygen has a mass of 15.99. Okay. So when we add those together, I have 18.01 grams. 18.01. 18.01. Now I put this in my calculator. 60 times 6.02, and I use the double E button to go to the 23rd. That gives me my numerator is now 3.612 times 10 to the 25th divided by 18.01. So what is my final answer there? 2.005 times 10 to the 24th. That is what the calculator tells me. Now that's not actually my final answer though. I gotta go back to my sig figs. I have 3 sig figs there. So my answer can only be the first 3 significant numbers. 2.01 times 10 to the 21st molecules. And that's the answer to number 1. Let me go ahead and clear off this page. Number 2, how many grams? Okay, that means that's my unknown. I want to find grams. Does 4.77 times 10 to the 19 formula units of NABR? Big, large exponential number. I know that means I'm going to be using Avogadro's. So I have formula units as my known and my grams as my unknown. Do I see moles? Nope. Moles goes in the center. So that means conversion 1 is between formula units and moles. Conversion 2 is between moles and grams. So moles is going to be on offense for the first equation and on defense for the second equation. So now let me rewrite 4.77 times 10 to the 19 over 1 times, I have 2 arrows, 2 fraction bars. Okay. My formula units are going to go on the bottom because they're on my left side of my arrow. My moles are going to go on the top because they're the right side of the first arrow because I'm on the first conversion. My second conversion, moles, is to the left of the second arrow, so it is the known. And grams is the unknown. 1 mole, always a mole. Formula unit, 6.02 times 10 to the 23rd. Okay. And molar mass of NABR. Na is 22.99, Br is 79.90. So when I add that guy together, I get 102.89. So that goes with grams because there's that many grams in 1 mole of the formula unit sodium bromide or the ionic compound sodium bromide. Both questions and statements are correct. Okay. So now I'm going to end up with 4.77 times 10 to the 19 times 102.89. That gives me my numerator 4.907853 times 10 to the 21st. And I'm going to divide that by 6.02 EE to the 23rd. If you do not use EE, you have to use parentheses or it's going to flip your answer and you're going to get a number like times 10 to the 42. So if you ever get too big a number and it doesn't mostly cancel, try again. 0.00815 is my answer. And how many sig figs? 3 sig figs. And my answer, 3 sig figs. Because remember, leading zeros are not important. Okay, so there's number 2. Let me slide this up a little bit. Which element has a molar mass of 196.97? That's directly off of the periodic table. Which diatomic element has a molar mass of this? Diatomic, 2 atoms. So you got to take that number, divide it by 2, and then look on the periodic table. Okay. 6.02 atoms of vanadium, that's our known because it came with a number. We'll have a mass of what? Mass is in grams. I have to go from atoms to grams. Do I see moles there? Nope. Then it goes in the middle because these are mole conversions. So that's the hint. You need to have the moles at the beginning, middle, or end of every one of these problems. My first conversion, atoms to moles. Second conversion, moles to grams. 6.02 times 10 to the 23rd atoms over 1 because that's my known. Known goes over 1. 2 arrows. Atoms to moles. Atoms is on the left. That means it's the known. Knowns go on the bottom. Moles is to the right of the first arrow. So it is the unknown. It goes on the top. There's 6.02 times 10 to the 23rd atoms in 1 mole. And my second unit conversion, moles to grams. Moles is now to the left of the second arrow. So it goes on the bottom. Grams goes on the top. If you ever get confused and you write it the wrong way around, it won't cancel. If something doesn't cancel, you probably did your conversions upside down because it has to be in the top and bottom to cancel. So if you had moles in the top and moles in the top, that's moles squared. That's not what we're looking for because we want to get rid of it. If you ever notice that, one of those conversions is upside down, so it won't cancel. And how many grams are in 1 mole of vanadium? Molar mass, specific to each guy. So look on my periodic table, vanadium is 50.94. There's 50.94 grams in 1 mole of vanadium. Now in this one, if you notice, this is also the same. Yeah, go ahead, cancel it. Okay, all that I'm left is 50.94. So that is my answer, except, is it correct? How many sig figs do I have here? 3. So my answer has to be rounded to 3 sig figs, 50.9. Okay, 7 is going that same way. It's going from atoms to grams. I don't see moles, so it's in the center. So your problem is going to set up exactly like number 6 did, except for you're not going to be able to cancel. So just go slowly and make sure that you use parentheses on the bottom if you're not using the EE button. Because remember, the calculator, you can type it in 6.02 EE to the 23rd. Okay. Number 8, atoms to moles. There's only 1 unit conversion that goes from atoms to moles. What's the name of that? Avogadro's. 1 mole is 6.02 times 10 to the 24 somethings. And in this case, the somethings is atoms. Okay, let me move this guy up. 3.70 moles of hydrogen will have a mass of what? What is my known? 3.70 moles of water will have a mass. That's my unknown. I'm going from moles to grams. Moles is already there, so I don't need to add it in the middle. I just have 1 unit conversion. What converts between moles to grams or grams to moles? Molar mass. 3.7 moles over 1 times 1 arrow, 1 fraction bar. Moles is on the bottom, grams is on the top. Moles cancels. 18.01 grams in 1 mole of water. So what would it be in 3.7 moles of water? The calculator answer is 66.637 grams. Okay, but that's the calculator. Find out how many sig figs are here and round your answer to that many sig figs. All right, let me clear this again and go on to number 10. 10, 11, 12. Let's see if I can get them all in 1 page. All right. Milligrams to atoms. Oh, that's a new one. We haven't been doing that one. So we're going to have to do some more steps here. Milligrams has to go to grams first because molar mass is in grams. And then we can look for our missing guy of moles. So this time I am going to do milligrams to grams as conversion 1, grams to moles as conversion 2, and moles to atoms as conversion 3. So this is my conversion arrow for conversion 3. This is my conversion arrow for conversion 2. And this is my conversion arrow for conversion 1. That'll help you keep it sorted since there's a lot of them, right? Use the color coding on your own. Known on the left, unknown on the right. Okay, and that will change each time. Magnesium is the known for the first one. grams is the unknown for the first one. For the second unit conversion, grams is to the left of the arrow, so he's now the known. He switched. Moles is the unknown for conversion 2. Conversion 3, moles is to the left of the arrow, so he's the known, and atoms is the unknown. Go super slow. It's not hard, it's just tedious. You have to make sure you're going each step, each time. Take a breath each time you get a number done, and then go back. Take a breath when you get things canceled, because there is a lot of steps, but you can do it. You just got to go slow. We start off with our known, 32,600 milligrams over 1. How many arrows did I have? 1, 2, 3. 3 unit conversions. My first one is milligrams to grams. So you got to go all the way back to lesson 1 in module 1. There is 1,000 milligrams and 1 gram. Milligrams is on the left, so he goes on the bottom. Grams goes on the top, and then fill in their matching numbers. 1 goes with the gram, 1,000 goes with the milligrams. When I cancel here, I would now be with grams, and that's what we can say in conversion 2. Grams is the new unknown because the calculator could now tell us grams. So grams is the new known, so he goes on the bottom. Moles is the new unknown for conversion 2, so he goes on the top. Carbon has 12.01 grams per mole. That's its molar mass, right from the periodic table. Okay. And now our third conversion in orange, the known is now moles. So moles goes on the bottom. The unknown is now atoms. 6.02 times 10 to the 23rd atoms. Let's do the rest of our canceling. Grams, grams, moles, moles. So my answer is N atoms. Whew, we made it to the correct answer. Take a breath. Okay, that means you made it so far. Simplify, solve. How many sig figs does this have? 1, 2, 3. That's a comma, not a decimal. So round your answer to 3 sig figs. Number 11, there are 10 moles of phosphorus pentachloride. 10.0 moles of phosphorus pentafluoride will have a mass of what? How do we find out the mass of something? Molar mass. Okay, so for this one, 10.0 moles. And then to figure out the mass, moles goes on the bottom, grams goes on the top. I'll let you use the periodic table and find the molar mass of phosphorus pentafluoride to substitute in there. Make sure you round your answer to 3 sig figs. Okay. Once you have that, that is part A. That's the one here because that's the mass that you solved for. For the other part, start all over again. You have 10.0 moles of F5, and you want to find molecules. That's Avogadro's number in this one. Make sure your answer again is 3 sig figs, but you will use Avogadro's for your single conversion. All right, students calculated the molar mass of strontium iodide to be 307.13. That is the lab answer in this case, or the calculated answer, but not the actual answer. Strontium iodide, strontium. What group is strontium in? He's in group 2, so he has a +2 charge. Iodine, -1. So my formula for strontium iodide is this. Calculate its molar mass. And when you calculate from the periodic table, that is going to be the actual answer or the book answer. And then you can put it in to your percent error calculation. What's that formula again? Percent error is observed minus actual over actual, absolute value of the numerator times 100%. You should also have that on your equations page, so go write it down because it shows up again as we're going to start doing some labs. So there you go. So that was a quick overview of the 12 ones to watch through, correct your answers. If you're still stuck on any of them, go back and do the learning check again, try them again, and then send me an email and tell me specifically where you're stuck and what time you want to meet to go over it.